Everyone, thanks for joining our Productization of Big Data Streaming Analytics webinar today. My name is Ian Gomez, Audience Marketing Manager here at DataTorrent. Joining us on the webinar is Mike Gualtieri, Principal Analyst at Forrester, and Amol Kekre, CTO and Co-Founder at DataTorrent. Here are some logistics regarding the webinar. This webcast is being recorded. It will be available after the session has ended to watch again and share with your colleagues who are not able to attend our session today. We love your questions. Please submit your questions throughout the session. You can submit your questions via the Questions tab in your console, and we'll be happy to answer them after the presentation is over. Lastly, feel free to click the Attachments tab to view more relevant information regarding DataTorrent and our solution. Without further ado, I'll hand it over to Mike. Mike?
Thank you, and hello everyone. My name is Mike Gualtieri, Principal Analyst at Forrester Research. I cover big data, streaming analytics, and other advanced analytics. And I'm just going to give us a little intro to what we're talking about here today, and then I'm going to have Amol join us in the conversation. Everyone's talking about big data, but more these days they're talking about what big data gives us, which is a lot more knowledge. And we know that some people say that big data is like the new oil. That's far too limiting. We like to think that big data is more like the sun. It's virtually limitless, and it's coming at us very, very fast and all the time, which leads us to streaming data. And every industry has more of this data. And when you think of what streaming data actually is, it's not just specific types of data. It's all data because all data is generated in an instant. So it's even transactional data, right? Because those transactional data is potentially streaming. It's usage and behavior data, IoT data, social media, log data, and also data from the data economy as well. And so when we're talking about big data, the conversation quickly goes to analytics, as it should. And our perspective here at Forrester is that firms need 4 types of primary analytics. Descriptive analytics, that's your traditional BI. That's like your reports and your dashboards that you do on historical information. And certainly firms have invested a lot in that. But they also need predictive models, predictive analytics, that can help them predict with a certain probability what's going to happen in the future. And think about it. Recommendation engines are predictive models. Risk models are predictive models. So there's lots of different types of predictive models. They also need streaming analytics because you can't wait to analyze some of this data. So streaming analytics, which is the subject of this webinar, is all about doing analytics on data as it originates, as it happens. And then finally, prescriptive analytics is to what to do about it. Now, what's interesting is that streaming is sort of at the heart of what you do with a predictive and prescriptive analytics. And we'll talk about that more in a second. So if you look at sort of the uptake, streaming analytics has a lot of momentum here. If you just look between 2014 and 2015, you can see a marked increase in the usage of streaming analytics and predictive, for that matter, and other forms of advanced analytics. Analytics is hot. And all data, you have to think about it, all data originates as potentially streaming data because it materializes in an instant. An instant a transaction is made. So normally we think of data sitting somewhere, but it originated somewhere and it got there much later. So streaming analytics is all about doing that analytics now. And the reality is most analytics is usually done much, much later in the process. And that's really what traditional business intelligence is about. Streaming analytics asks a fundamental question, which is why wait to do those analytics? There's a lot of insights in that data that Forrester calls perishable insights. And they're perishable because if you don't act on them now, then the value of that data is lost. So streaming analytics will capture those perishable insights. A couple of quick examples of this, obviously fraud, right? You don't want to, you'd rather detect fraud right now rather than 15 minutes from now, a month from now, a day from now. some financial companies are looking at market data, but social media data, to looking for trading opportunities. Those trading opportunities materialize in a flash, and then they're gone. Again, perishable insights. In the world of IoT, here's a baby monitoring device that can determine right now if there's something wrong or if everything's fine. So there's been a big trend to talk about data lakes, but there's also streams. And data lakes are absolutely a necessity, because when you're building a predictive model, that's generally batch processing, and you still need descriptive analytics, but you also need streams. Okay, so when you're building your data lake, you also need to think about your streams. So when we look at streaming analytics, fundamentally, streaming analytics can detect and act on those perishable insights, those very valuable perishable insights. So our definition of that market category is, as you can see here. And basically, it's analytics from multiple sources to identify patterns, situations, and automate those immediate actions. And with that, I'm now going to bring Amol into the conversation, where we're going to talk about what to look for and what are some of the core capabilities needed for streaming analytics platforms. Amol?
Thanks, Mike. So let me introduce myself. I am the co-founder and CTO of DataTorrent, and my background has been I'm a Hadoop veteran, and I also led Yahoo Finance backend systems, part of front-end too. And in Yahoo Finance, we had a globally distributed data in motion architecture where we collected quotes data from different exchanges throughout the world, did all the ingestion, filtering, all the business logic required to run the financial sites, and distributed back to all the front-end servers. And these were 2,000 servers distributed throughout the world. And it required an enterprise SLA where you could not lose data, you could not drop data, neither could you have wrong results. After that, I went on to Hadoop, and I led the Hadoop team in Yahoo, where we launched Yarn. So what I'm going to do today is talk about where the big data ecosystem is, and then me and Mike will discuss various topics that impact big data streaming analytics. So the way I look at it is big data ecosystem so far has done very well over the last 10 years. It has grown, it has adopted, and it is taking off, and it has become a necessity in the ecosystem. However, it has had a very low success rate in launching products and meeting business SLA. The promise of big data to transform businesses into data-driven enterprise remains largely unfulfilled as yet. There's a lot of hope and there's a lot of reality because it's there, it has to happen, but it hasn't tipped over where you see everybody adopting it and going to production. And for that, we require next generation data platforms that need to focus on issues that are blocking enterprises from going to production and not just on functional coding. And the issues that lead to failure are mostly operational in nature. Because they don't, currently the big data ecosystem don't depend on commonly available expertise like for DevOps and security ops and other expertise for develop. And for that to succeed, the next generation platforms must completely own the operational aspects of big data products and have a clear separation of functional and business logic. Developers must not need to do anything other than developing just the functional logic. Operability and operational aspects must be baked in the platform as guiding principles. So why did this happen? How come 10 years of such a disruptive technology that's obvious to everybody hasn't yet matured on the operational side? It goes back to the roots of when Hadoop was done. When Hadoop was started at Yahoo, the question that was asked is, how can I do search indexing better? Because Google was indexing and Yahoo needed to catch on. And that produced MapReduce. And an entire ecosystem in big data today is based on MapReduce. The genesis of the low production success of Hadoop lies in the fact that MapReduce is at the core and it's hard to learn. And when you migrate a lot of projects from outside, products from outside pipelines into big data, requires a very high threshold to learn MapReduce. If people had known how successful big data has been, the question that would have been asked is not how can I do search indexing better, but the question that would have been asked is if I had 1,000 servers, hundreds of nodes with memory, hard disk, CPU network, what all could I do? And one of the answers would have been that I would want to do big data streaming analytics on these data that's coming in. And if that is the case, you really require platforms and products that are tailor-made for big data streaming analytics and not slapped on to MapReduce. And the use cases cannot be shoehorned into MapReduce basis of ecosystem. Time has come to look at new next generation platforms that actually address big data streaming analytics the way it should be. Just to get a perspective on that, streaming analytics is not just in memory. It's necessary but not sufficient. Streaming analytics is also data in motion because data flows. So think about feeding these data lakes of big data. You can either move the water in trucks, or you can let the canals continue to flow water into the lake. The world revolves. The water in the world moves through canals that just and streams that just go into the lake. You don't move trucks around. Therefore, moving data through file copies and MapReduce the ecosystem, even if you do it in memory with the RDD, is not sufficient. It doesn't work because it's not big data streaming analytics, and that's where data in motion comes. So before we go into discussion, let me just at a very high level take a view of what big data should be. Today, big data is big and it's getting bigger, but at the base is not wide. It's still MapReduce. It's a lower base. For big data to be productized and be adopted by different industries in the enterprises, you need big data to be bigger and wider. And the wider use case is clearly upcoming big data streaming analytics. And with that, Mike and I would go and discuss various topics, various subjects, various factors that are required to successfully operationalize and productize big data streaming analytics. Mike?
Yep. Thanks, Amol, and that's a great introduction. We're going to talk about 5 different things to look for in a streaming analytics platform, and the first one is scalability and performance. I mean, we know just the very nature of streaming is that there's a lot of data coming fast, and it can be very spiky. And so you can't have a streaming analytics platform. It's sort of like the first real requirement is to be scalable and performant. And in today's world, that cannot be done with a simple single server with multiple cores. The only possible solution to that is a scale-out architecture, but all scale-out architectures aren't created the same. It also has to have enterprise quality. So Amol, I want to ask you, what do you see as the ideal scale-out architecture for a streaming platform, and what are some of the the key things that it has to be able to handle?
Absolutely. And Mike, this goes back to the need to be wider and need to not just think of big data as shuffling files, maybe in memory, but still shuffling files. So scalability has multiple factors. I would name maybe 4 of 5 of those. Number one, you already mentioned, you have to be big data compliant, and big data compliant is scale out, not scale up. There's no
right.
two ways. You cannot scale up; it has to scale out. Number one. Number two, part of the scale out is the platform should depend on commodity hardware, not require some special hardware. The algorithms that the platform uses underneath should be linearly scalable and need to handle terabytes of data. And it has to be very apparent on a piece of paper with a pencil. You don't need to have a lot of depth there, in the sense that it should be very clear in the elevator pitch of that platform. So what is required for a big data streaming analytics to scale? Number one, you need to be thinking data in motion, not data at rest. The pipelining, the parallel pipelines, the apps, the unifying, the fan out, the fan in, they all have to address towards data in motion. The algorithm must be based on that. Number one. The second biggest aspect of data in motion is to scale out is a requirement to have a publisher-subscriber mechanism underneath, which means that as you scale out, you can have more subscribers connecting, and you have more and more growth, and you fan out accordingly. Data at rest with file copies just simply cannot do that. The products must have underneath building blocks, buffers that are basically pub and sub, publisher and subscriber based. And then, as you have apps that scale, they really need to scale linearly. And a big data streaming analytics products must have all of this aspect. Scale out, commodity hardware, algorithms that are meant to linearly scale, and underneath building blocks must be publisher subscriber based.
Yeah, and I think what's interesting about the performance aspect of this too is that, in my mind, when I think about performance and streaming, I think 2 dimensions, right? There's ingestion, right? How quickly can I simply accept these events, the streaming data that's coming in? But then there's the analytics side of this, which we're going to talk about next, what we mean by the analytics. But then there's the analytics side, which is the actual processing. It's what am I looking at? What am I going to do with this data? That also has to scale. And I think to your point, the only way to do that is a scale-out architecture. And data streams, and maybe you can confirm this, data streams can be consistent, but they can also be very spiky, right? So there's a certain amount of elasticity that's essential in that scale-out architecture too. If it's a e-commerce site and you're entering sort of the holiday season, you have to be able to add resources to that streaming cluster.
Absolutely. And that's where the publisher subscriber wins against a file copy, because a publisher can take on more subscribers without impacting the previous subscribers. And if the platform and the product underneath allows that, you can scale linearly. You can add more subscribers to handle more load, or you can take away subscribers to take away load. And the other part of performance for streaming analytics is that it again goes back to the current big data paradigm, which is basically compute going to data. Since you have files, and it was all indexing, all the current ecosystem, whether you have Pig, Hive, Spark, and all of them, have inherently in their core architecture this notion that you always have compute going to data. And the horrible part of this is that that's all you have. That's the kind of base you have for the whole platform. In reality, and especially in streaming analytics, when you have ingestion and then analytics and all of this to be done, you need both. You need compute going to data and data going to compute, especially because the data in IoT or as in spikes comes fast and furious. And you need to have a platform that handles both, not just data locality, but also compute locality. And it has algorithms good for both compute and for data in motion to route data. And today in Hadoop, in big data, there's a lot of cost that we pay for serialization. You need to have algorithms that circumvent that also. And all those things have to be taken care of, because streaming analytics requires a different eyeglasses, different way of looking at things. And you cannot be shoehorned into an old assumptions.
Yeah, and I think another important point, you made it in your intro, that you said, well, streaming platforms have to be in-memory platforms, but that's not sufficient, right? Which I agree with.
Yeah.
But I do think we need to emphasize that, they have to be in memory. That has to be, they have to be designed around in memory. And that's sort of what makes a streaming platform, one of the things that makes a streaming platform unique compared to sort of batch processing clusters, such as just pure Hadoop. So,
absolutely.
Let's move on to our second requirement. Scale and performance is you can't even start if you don't have that. That's sort of the streaming part of it, right? But then there's the analytics part of it, which is actually doing something to that data. Because, for our listeners here, when we say streaming and we have all this data coming fast, we're not just taking it in to land it somewhere. Okay, streaming analytics platforms certainly can do that, but the highest value of a streaming analytics platform is actually to do the analytics on the data while it's in motion and while connecting to different sources. So Amol, I wanted to ask you about, to sort of explain what streaming analytics is. What are some of those streaming operators that people are likely to use in a streaming analytics platform?
Absolutely. Mike, you nailed it. One of the other fundamental difference in streaming analytics compared to data at rest is you actually analyze before you put data to rest. You analyze while you ingest. You have ingestion going on, but you start analyzing immediately in memory as it's happening, and not wait for the files to occur and then think about it, because the data may be already perishable. So great point. So the operations that streaming analytics needs to do in terms of ingestion and analytics are two buckets. One is analytical operators, and you need a whole bunch of dimensional computations, various joins, filters, rules, rule engines, a whole bunch of mathematical operators, computations, ability to do algorithmic operators, ability to do parsers, in-memory stores. All of that needs to be there. But to make that very, very more powerful, you also need all different connectors for different technologies, different message buses, different databases, different file system, NFS, FTP, S3, Oracle, MySQL, Kafka, Flume, you name it, and you need to connect to everything in and out. And different protocols like WebSocket, HTTP, you name it. These platforms need to be able to be live, to be able to allow people to extract value as it's happening and not wait for something to go into the file and then analyze. And you need to have a system that actually not just connects to all the connectors today, but has a mechanism that is very clear that if something new comes up, it will be very easy to connect. And the fundamental building block for that I'll bring up for the first time, that also is very hard in Hadoop, in big data today, is the ability to run any code, any user code as is. If the platform is completely separate functional logic from business logic, you will be able to put any code that's commonly available, notably Java, and just run it. And that is required to able to connect, to do two things, different connectors, because all the connecting clients have the client library, and you want to be able to run it as is. And you also have a whole bunch of operational analytical code out there in business logic, which you also wanted to port as is. So it's very important for the platform to also allow any user code to be run very quickly in the platform.
Yeah, and Amol,
Yes,
Amol, that brings up a great point when you talk about any user code, because it also brings up the point about the development tools used to create the analytics, that real-time analytical workflow. I absolutely agree. You have to be able to run any arbitrary code, for example, in Java, but the best platforms, including DataTorrent, also provide a library of pre-built operators, right, with the tooling that lets someone sort of do a drag and drop. So you've sort of got, for an enterprise, you've got a library of operators, right, that you can sort of assemble together. But if you want to do something very custom, you can drop down into the code. And I would say that most enterprises will want to begin with a library of operators and then drop down if they have to.
Yes. So the other aspect of big data streaming analytics is the tooling and the monitoring that comes along with it. And it is dramatically different than data at rest, because data is moving, which means the platform has to communicate data back. And as you create the apps, you need to have a whole bunch of operators that DataTorrent provides. We have 400 operators with different common functions and different commonly used analytics tools, ingestion, connectors, in and out, all of that. And that really brings down time to market, because remember, the whole aim is to be able to enable people to launch to production very quickly. And the drag and drop connect.
Yeah, and I think the reason why that's so important is because a lot of streaming analytics platforms focused on that first thing we talked about, which is scale and performance, which is absolutely critical, but then sort of left the programmer to their own devices to sort of do the analytics part, right? So more of a framework than a complete platform. So, at least from our point of view, covering streaming analytics for enterprises, we think that tooling part for the analytics is essential. Why don't we move on to our third sort of requirement, which is to feed data lakes. We've expressed the value of doing analytics in real time, but there's still that need to feed data lakes. And I think one of the interesting things about streaming analytics, again, that analytic word, right? Some of those analytics can be more like ETL type of analytics. So you can actually do some pre-processing on that data while you land it in Hadoop for later batch analysis. Amol, can you talk a little bit more about that?
Absolutely. So to bring out the point, and it's great question and great point that you're bringing out. This is not a statement to say streaming analytics will replace everything. It doesn't. The ecosystem will have streaming analytics. It will have long historical analysis, and you'll have all of that. In today's laptops, we have browsers, we have Adobe's, and we have different tools because we have different usage. Similarly, if you look at big data as a collective resources of CPU, network, and hard disk as a part of a laptop, you will have different use cases. So feeding data lakes is absolutely one of the primary use case for streaming analytics, is to get the data from different sources and be able to scale it parallel, have more data coming in, handle it, no problem, do all the analytics, maybe massage the data, munch the data so that the later on analytics can handle it better, write in a particular format that you want, catch errors, and so on and so forth to actually optimize the data lakes too. But at the end of the day, you should be able to land the data properly and as required in the data lakes, and also be able to take it out to load other systems. So that absolutely is very critical. And one of the things that you also want is, as you're doing it, you also want app dashboards that show the data of the application metrics as to what's happening and how much you're succeeding. Have you fed all the data properly, and update all the other tools that manage the data at rest. Yeah,
and Amol, there's a fair amount of noise in some types of IoT data, for example. Right, like you could have sensors spewing out every second a temperature, for example, right? And there may not be a need to store, a temperature every second from 1,000 temperature sensors, right? It may be more important to store the average of that temperature every minute. That's perfect, right? Because even that simple use case, a streaming operator can exist to take the average of that sensor over 1 minute time period, and then store the 1 minute. The 1 minute temperature. So I've heard a fair amount of use cases about that sort of application as well. And we have customers in production doing that today, and that's absolutely very sweet spot, because what you don't want is all in IoT especially, you have all this different data coming all the time, and what you really want is the precise data required, and data munging or data averaging and alerts and whatnot. So that when you go and analyze your data at rest, say do a historical analysis, you only have data that you need as such. So that's a very critical part of streaming analytics. Yeah, and we see, just the topic of IoT, we see streaming analytics as it's sort of the brain of an IoT application. It's sort of absolutely essential there, and not just for filtering, but just for the analytics as well. Let's get on to our fourth topic, which is it's going to be operable and enterprise ready. We talked about the criticalness of the streaming applications and how they're there for perishable insights. These aren't casual applications; these are mission critical applications. And enterprises like banks, large tech companies, manufacturing, they can't tolerate downtime, right? So these systems have to, so what are some of the enterprise qualities that a streaming platform needs to be able to be enterprise ready?
Absolutely. So this is a great point, and I think in this discussion we had, this is going to be the crux of what it's all about. This is what is required for big data streaming analytics products to actually be enterprise ready and be able to launch and increase the success rate of big data products today. This is the guts. Mm-hmm. So let's walk through it. And there are various aspects. Operability is very hard to define as such, and it's not taught in schools, but there are various aspects. And if you put a cap, put a hat, put a cover in terms of what it takes to be time to market, and we step back from there and see what all is required, we can go through a lot of different aspects of it. And I'll go through them one by one.
And I even want to, and Amol, I even want to go before that. Well, I kind of want to go after that first, which is, okay, what if a node goes down? Can I recover? What if the cluster goes down? Can I recover? Right? These are, high availability is really the most important factor. And I know that there's differences in strategies for doing that. If a node goes down, maybe it just keeps going, but do you lose data? Do you lose that, do you lose potentially a critical part of the stream?
Absolutely. So before big data streaming analytics replace the current enterprise software, we need to meet the SLA. And if you look at time to market requires time to develop, time to certify and launch, and most important, time to operate, as you talk about, right? Let's first take time to operate. The app that is running and it's being operationalized and is running in production cannot lose data. If you want to run your enterprise business and make your enterprise data driven, it better match the current SLAs of different current enterprises. And that means you can't lose data. You You can't have outages. If a node goes down, if the cluster goes down, you have to be able to recover and continue. And fault tolerance is not just sort of restarting the app. You cannot lose the app state, you cannot lose data in motion, and you cannot lose your master state. You have to be fault tolerant on all aspects of it. And you have to be able to do exactly once, at least once, all different, at most once, all of them. And it has, for big data streaming analytics to displace the current products, you got to meet the SLA. You got to have business rely on that, and you got to be able to have a data-driven enterprise, which means that let's say your app is running and you want to make an upgrade. You can't shut it down. It has to be rolling upgrades. It has to scale up as more data comes in. It has to scale down, and so on and so forth. You have to meet all the requirements while you're operating. And in addition to that, the total cost of ownership while that's happening should be low. Now that's the operational part of it. Now let's see what happens when you're developing it. You need to be able to develop these apps and operate it and extract value with the current expertise you have. One of the problems MapReduce had was the expertise to do MapReduce was very rare. And that meant that first of all, asking people to take current pipelines and redoing it MapReduce was very hard. It resulted in a lot of failures. So you need something that leverages easily available expertise, like say application level Java, that people can write, and the platform takes care of everything. And when you're operating, the platform must integrate into the current dev tools, the current DevOps tools. You don't need to have something completely new and new clusters. Whatever they're supporting today should be just as is. So a native Hadoop platform is much better because the company has already invested in Hadoop, operationalizing Hadoop and now monitoring Hadoop, and then you don't have to add anything else. It becomes no additional cost. It becomes no additional expertise. It's expertise that you're already planning to have. And you should have open web services. You should have open alerts. You should integrate into all the other dev tools that the people have. What they're doing should just work as is, which means that when you start plan to certify and launch, the time it takes and the ease which it goes through is better, and you have much higher success rate. You also have something else that is a wrench in the production launch, which is security. Banks, even IIT, any company cannot have data cannot have a platform that's not fully secure. Hadoop has adopted Kerberos, and a lot of work has gone into make Hadoop secure. The platform should leverage that. A big data streaming analytics platform should leverage all those investments, because open source as is takes a little bit longer to mature, but when it does, you need to be leveraging that as is and not have additional headaches. LDAP, other security, making the stream secure, all of that has to work as is. And then when you certify and you launch, enterprise will be able to have the same SLA and legal requirements satisfied before they start using it in production.
Yeah, I think all of the. Oh, I just wanted to say, I think all of those things that you just talked about are particularly. I mean, I know you're talking about enterprise quality, right? But the streaming platform isn't going to work in a vacuum, right? It's going to work in conjunction with all of these other applications as either data sources or as data sinks, and so things like security and LDAP and supporting some of the normal enterprise infrastructure is critically important. But go ahead, keep going.
Yeah. So what has happened in current big data is, as Mike had correctly pointed out, the big data ecosystem started by saying, here's the code, go take the code and run with it. Oh, by the way, figure out how to operationalize. And that is the crux of why we have such a low success rate in production. The platforms that are coming, and especially DataTorrent, has to have a completely different function. It should say that we will take care of operationalizing it. The platform will take care of all the stuff, and we make sure that it's very viable, thereby just freeing you up to do the functional coding. And it has to be extremely DevOps friendly. It has to be extremely security ops friendly. It has to integrate with all the current tools, different sources, different things, and make that as a guiding principle on which the platform is built. Because without operationalizing, without supporting it in production, the product will die. It will not launch. It will be uncertified. It will break some legal rules, and pretty soon you're back to square one. Banks cannot have these issues where operationalizing is not done as a part of the platform, but is done by someone else, and then pretty soon something that should take 6 months takes 4 or 5 years, and then you just sit there kicking tires. And the worst thing is that some other company, this is not an optional choice. Being data driven is a must, because your competitor is going to be data driven, and then it all ends very badly. So you have to get it to work and you have to succeed because your competitor will.
Yeah, I think that's a great segue to our fifth and final topic, which is time to market. And really, what we're talking about here is applications, because that's what this is all about. It's ultimately about applications, and we call this streaming analytics. It's about real-time analytics, but I actually think of this as the new application development platform, the new application development paradigm. Right? Many years ago, we used to talk about Java application servers, like web servers. They were app servers. And that was a request and response world, right? We're now in a streaming world, right? So to your prior point, if you're going to be data-driven, if you're going to be a real-time data-driven organization, you need a streaming platform. And so there has to be an ability to create new streaming applications, but they have to work in conjunction with ERP systems, with web, with e-commerce systems, and with other applications within an enterprise, and maybe even exposed services. So, Amol, what do people have to think about in terms of developing these applications, and especially in connecting and interacting with other enterprise applications?
Great question, because that's really what it's all about. It's time to market. And what enterprises should focus and think about it, what does it take? What am I doing, and what does it take for me to be able to launch to production? Now, the dirty little secret of big data is that we're not necessarily doing new applications as business logic. What we're really doing is scaling them up, is becoming big. And we're doing something that we have been doing before, but we are doing it at a much larger scale, which means that if I have to rewrite everything from scratch, it's a dead end. I need to be able to reuse my code. I need to be able to leverage the expertise that I have, and in terms of languages, in terms of DevOps. And that's the only way I can get my time to market lower, because the components are time for you to develop, time for you to certify, time for you to launch, and then onwards time for you to operate and total cost of ownership. So you need these platforms that are easy to use, take care of all the operational details, and require the developers to simply not know more than, say, app-level Java and nothing more. And they take care of a whole bunch of other stuff for you ahead of time, so that as you go and go to production and you develop, and along with the tooling that they provide, they really are focused towards reducing the time to market, reducing the time to develop, reducing the time to integrate. Because you say you have to connect to ERP system, you have to connect to databases. They're not going to go away. You have to connect to web servers. You have to have WebSocket data going out. You have to have web services. You have to have all of that is meant to integrate. And you need to have a product that focuses on that as its guiding principle. Doesn't hand code over to users in open source and say, figure out how to integrate. It has to be part and parcel of the DNA of that platform, with the desire to integrate, the desire to reduce time to develop, the desire to have all kinds of certification tools, with the desire to love DevOps and security ops, and understand that they are a must-have. They are the ones who run the product, and make sure that the cost of ownership, when you have fault tolerance, when things go down, when you have to do upgrades, when you have to run multiple apps simultaneously, all of that should be taken care of, and there has to be concrete effort done by the product and the platform to reduce that thing. You cannot reduce time to market if that's not your primary goal. The product and the platform must have time to market as a primary goal, and then come back, then step back from that and figure out what is required to do so.
Thanks, Amol. So, everyone, you should look at streaming analytics platforms not just as an analytics platform, but as an application platform. And please refer to the 5 topics and requirements that Amol and I just talked about. I'm Mike Gualtieri, Principal Analyst with Forrester. I'm here with Amol Kekre, CTO of DataTorrent, and we will now take questions and give you some answers from the audience. Thank you.
Awesome. Thanks, Mike and Amol. That was a great presentation and discussion. We have some questions in the chat window, and we'll try to get to most of them with time permitting. So for the first question, I'll address it to Amol. Is big data hype or reality? If it's reality, what do you think the future is? Amol?
So big data is reality, except it's a reality with pretty low success rate in production today. But the problem with big data is it's very simple. There is no alternative. You don't do it, you don't become data-driven, your competition will, and the matter ends very badly. And we're going to see the disruption faster, much rapid, and fast and furious. So there's no escaping from this reality. So think of big data as the cell phones in India and China. Today there are more cell phones per person in those countries than before, and communication has become very cheap, very easy, less than a cent a minute or something. It's really cheap, right? But think of big data as the same ecosystem without smartphones. You're still using phones only to call and doing nothing else. You need the app ecosystem to develop, to come to smartphones, to come to WhatsApp, to come and do other stuff. And that's why Hadoop is. It's reality. It has already disrupted the landlines. The cell phones have already taken care of that. Landlines are dead. What you don't know as yet and what you're not seeing is the emergence of big data apps. Big data apps that helps you extract value and go to time to market faster. And that's where we are. We are at the crunch point, at the inflection point of big data streaming analytics and other aspects of big data where the apps will take off. You'll see more and more companies being able to extract value faster and take over the competition and take a bigger market share and time to market. That's where we are. So it's reality. It's happening. You don't know who's going to win, but people who will win will get time to market faster, will use products that are enterprise ready, and will be able to do proper bets. And people who don't, the enterprises who don't, are going to pay a heavy cost. And that's where we are right now. We are at a place where companies, as they understand how to go time to market, use apps as the bigger apps emerge, will be huge winners. And you're already seeing that.
Awesome. Thanks, Amol. So our next question is, what is the difference between open source and commercial streaming platforms? Mike, do you want to take a crack at this one?
Sure. Yeah. So, well, sometimes there isn't a difference. Just to break it down, there are some streaming analytics platforms that are completely proprietary, meaning that code base is proprietary. There's others that are completely open source. That open source, it could be mostly in the Apache software foundation. And then there's commercial companies that are based upon the open source, but then add some proprietary commercial value. And what we're seeing in the market is sort of a vibrancy in all of these things. One of the problems with the streaming market is there's so many open source choices, out there, and there seems to be a new one every few months. So there's a lot of choices out there. I think what the commercial companies are doing is they're adding enterprise value on top of that open source base, so that enterprise customers have sort of the best of both worlds. They have the benefit of innovation in the community for the base, the core functionality, but then they have a commercial company that's focused on what those enterprise qualities are, many of the things that Amol and I discussed during the webinar.
Great.
Amol, do you want to add anything? Hmm?
Yeah, I think you answered it extremely well. Open source by itself is a necessity, but it's not sufficient. It's necessity because you don't want to bet on proprietary platforms, and today's streaming analytics platforms proprietary are very costly. The cost dime a dozen, and it's like selling cell phone for a cost higher than landlines. It will disrupt. So you need to be open source, but that's not sufficient. That's necessary, but not sufficient. You need to be enterprise quality, and that's why you require products like DataTorrent that come in and provide all the tooling, all the certification, all the fault tolerance to bridge the gap. And the gap is getting shorter and shorter, and these products are viable so as to disrupt and like WhatsApp disrupted the whole world, I guess. So it's coming. It's coming where open source software with proper enterprise tooling is reaching a point where just proprietary streaming platforms will be disrupted, and a whole bunch of enterprises out there can leverage the price points, the cheaper price points, to actually get more value. Think about it this way: 10 years ago, only Nasdaq, NYSE, Reuters, Bloomberg could use huge streaming analytics underneath. Today, that level of technology that we had in Yahoo Finance is now available in mass market, along with toolings, and it's no longer Just like Google disrupted, with search indexing the whole world, it's no longer a private to just some companies in Silicon Valley. These level of streaming platforms are available in open source with commercial tooling that can now be used for enterprise quality across mass market, and it's fun.
Great. We have another question in the window. I keep hearing about streaming and batch. How do you compare those?
Okay, so let me take this. So streaming versus batch. It's a question as such. It's true. If you look at underneath, one is streaming, one is batch. In reality, what you have is continuous data architecture that can handle streaming and batch, and file copy architecture that can't handle streaming. In reality, what you really have is data in motion and data at rest. So when you have file data that is at rest and you have to do something, it's fine. You can do it with different architectures. But a data in motion architecture can easily look at hourly files and give results much faster at a higher SLA, at higher enterprise than say MapReduce. And similarly, the same architecture can do streaming analytics, because if you can handle unlimited data, you can always handle limited data. What has happened for streaming versus batch is because this concept of Lambda architecture came about, and the fundamental premise of Lambda architecture was that streaming platforms can't match the SLA of file-based platforms, which in my mind is simply not true. Reuters and Bloomberg, when they send data out, the SLA matches or beats SLA for data at rest any day. So if you have a open source platform that matches that SLA, that matches that kind of enterprise quality, your streaming platform can do both streaming and batch. You will need different architectures for say graph analysis or historical machine learning and so on and so forth. You may require different platform, but that's not the same as streaming versus batch. Streaming versus batch can be done by the same platform. For example, one of our customers are doing model scoring, distributed app in Hadoop doing model scoring at under 1 millisecond latency. Okay. Now they are doing it in data in motion, but they may as well do it with data at rest. Doesn't matter, because the streaming platform can handle both.
Great. And our final question, where does streaming analytics fit in IoT? Mike, you want to?
Yeah, sure. I'll start. Well, I've already said it, that streaming analytics is sort of the brain of IoT. It's the thing that can process all of that data, do the analytics, run the models in real time, and figure out what's happening and what to do about it. A lot of the talk in IoT right now, in IoT and sometimes IoT platforms, has to do with communicating with devices, sort of shuttling the information back and forth. It really has to do with the creation of the stream. But what do you do? How do you analyze that data in real time in a command and control environment? Potentially a control environment, right? A lot of times it's just sensors, but sometimes there's actions to be taken on it. So I think streaming analytics is sort of that brain. It forms the heart of an IoT application. IoT by definition is streaming. It's streaming data, and so I think streaming analytics platforms is just an essential component. It's that app paradigm. It's that new app paradigm needed for IoT applications. Amol, your perspective?
Yeah, so you nailed it. I mean, absolutely, streaming analytics is the brain of IoT. And IoT is a use case that fits streaming analytics, ingestion analytics very well. And I'll tell you why. If I think of massive monsoons in India we used to have, even in, say, Brazil, and the water's flowing and it's going towards the lake, you cannot order enough trucks to move that water around. It has to flow just as it comes. IoT produces monsoons. It produces so much data that your platform must ingest, as Mike said, filter out data, give the averages. Like, all that has to be done as is. You cannot even imagine landing all that data first and then think about it. Because if you think search indexing is huge, IoT is 100 times more than that. You're going to have smart meters. Every house is going to have like 15 smart meters. Cars already have so much data. You think of this as massive deluge, like Niagara Falls, the Brazilian rains. You cannot move data in trucks. It has to be massive rivers, canals flowing, and the data is coming in, and that's classical data in motion big data streaming analytics, where you keep filtering. Think about dams are being built, and you filter out something, and you filter out something, and eventually it reaches a lake for you to do analysis. It's absolutely the perfect fit. Big data streaming analytics is a perfect fit for IoT. You cannot, big data will never solve IoT without streaming analytics. You need to have that.
Awesome. Well, that wraps up our webinar today. I want to give a special thanks to Mike Gualtieri and Amol Kekre for their time. Look out for more webinars by DataTorrent in the next few weeks. For more information about DataTorrent, visit our website at www.datatorrent.com. Have a great day.